The aim of this video is to look at GCSE Edexcel Chemistry Paper 2 structured questions, mainly the 6-mark questions. Main feature will be triple, but combined science can also benefit from this. I have selected a range of questions based on the additional information and with some focus on what I feel could be your 6-mark questions. So the first question I have chosen in front of you is where you have two substances which are mixed in a beaker. Now when you are attempting 6-mark questions, what I would do is I would read the question. It's a rate of reaction question, as it says there. It is basically mixed, placed on a cross with a piece of paper, and we time how long it takes for the color product to be produced, or a precipitate to be produced, or when the cross disappears. So that's what we're looking at. Now this person or this experiment was done 3 times. In experiments 1 and 2, there is no change in concentration. There is a change in temperature, and what we notice is that the rate has increased there. So what we notice is the rate has increased. The time taken for the cross to disappear from experiment 1 to 2 has gone from 320 seconds to 80 seconds. Then if we look at experiment 2 and 3, concentration's gone up by 4, and what do we notice? The time taken for the cross to disappear has gone down to 20 seconds. In other words, the rate has gone up. So use your results of these experiments and explain in terms of behavior of particles the effect of changing temperature and changing concentration on the rate. So there are 2 key things we need to do here. So for 6 marks, we've got to talk, or we've got to write in terms of temperature, and we've got to write in terms of concentration. For both, we've got to use collision theory. So what we will do is, collision theory states that for a reaction to occur, particles must collide, and with sufficient energy. That's a very important point, and we call this sufficient energy, I'm just going to call it EA, which is activation energy. So let's take each experiment at a time. So experiment 1 to 2, temperature increased. Temperature doubled, increased. So I'm not going to write everything. When temperature increases, there is no change in concentration, so the number of particles in solution is the same. Particles gain kinetic energy. When particles gain kinetic energy, particles move faster, and we will say they collide more often. So the frequency of collisions has gone up. So what I will actually say here is that the frequency of collisions has gone up, so there are more successful or efficient collisions per unit time per minute. And you could then say more particles collide with energy greater than activation energy. That's perfect for 2 marks. Or for, let's say, level 2, 4 marks. You will not get 6 marks unless you talk about concentration also. So now what I'm going to do is I'm going to talk about concentration. So in terms of concentration now. So in terms of concentration, when concentration increases, there are more particles per unit volume. In the solution there are more particles now if you don't want to use that. Note the concentration's gone up 4 times. That means there are 4 times as many particles in this solution. So what happens? The number of frequent collisions, actually let me rephrase this. There are more frequent collisions. Alternatively, you can say the number of collisions has gone up 4 times. There is greater frequency of successful collisions per unit time, per second. And therefore, there are more collisions with energy above activation energy. And that's how you would tackle a 6 marker here. Okay, so that's basically, I would say, how we would tackle a 6 mark question here. Next, now pause this video at your convenience. Now I've got a selection of questions here. I don't intend to go through all of these questions. There's a question here which says describe the advantages and disadvantages of using biomethane rather than natural gas here. So what would we do? Again, it's a 6 marker. This may or may not come up, but I think the rates one, I think is more likely. So what I'm going to do is I'm going to put this into a table. Biomethane, natural gas. The question is saying, look, I'm underlining advantages and disadvantages. So let's do advantages and let's do disadvantages. You can bullet point your responses on this. So what's the advantage of biomethane? It's renewable. It has low energy costs. So I'm just giving you main bullet points. It's renewable because plants can be regrown. It's low energy cost because we can work at lower energy. It's carbon neutral, meaning the amount of carbon dioxide that's released when biomethane is burnt is same as the amount of carbon dioxide used by plants for photosynthesis. What about its disadvantages? Well, it's a slow process. It burns less efficiently. Batch process, because when we make biomethane, it's not a continuous process. We work in small amounts, so it's labor intensive. So it can create, it can increase costs. Also, there is a ethical factor here that the land that's grown for crops for food is now used to make biomethane. That could increase cost of food or result in shortages. Natural gas advantages: efficient, produced quickly, gives us more energy. Disadvantages: non-renewable, produces carbon dioxide, carbon monoxide, sulfur dioxide, so releases all of these pollutants into the atmosphere. Okay, so that's how you would tackle that. The next question is actually, I would say, a really, really important question. It's on triple paper, it's triple content only, and it's about identifying ions. So the question is saying, describe So let's highlight it. Describe the test a student would carry out to identify the ions in ammonium iron sulfate. Now please note, it's ammonium, it's iron 2, and it's sulfate. So let's look at each one. Now if it's a solid, okay, so if it's a solid, it doesn't really, the student was also given sodium hydroxide. What I would do is, I would make this into a solution first because it's easier to deal with solution. So let's dissolve the solid into a into water, and ammonium salts are soluble, so it's going to dissolve in water. And then let's add sodium hydroxide here to ammonium sulfate. You could gently heat here, and this will give off some steam or some smoke, and you test that with red litmus paper, damp red litmus paper, and it will turn blue because ammonia is given off. Test for ammonium, 2 marks. What type of reactions occurring? Ammonium is reacting with sodium hydroxide to form ammonia and water. Okay, so here's an equation, appropriate equation for the reactions. With iron, when you add sodium hydroxide, you will get a green precipitate formed. Fe2 plus 2OH minus forms FeOH2. So there's a test for iron, it's a precipitation test. The test for sulfate ions, and you've got to learn these, is you add a solution of either barium chloride. You could also add barium nitrate solution. You will see a white precipitate formed, and the solution and the ionic equation is barium plus sulfate ions. I'm putting state symbol, gives you a white precipitate of barium sulfate. I'm really convinced that there will be a question on ions test, anions and cations. Okay, right. So that's another type of a question, and you will see later on that there are some repeat of these questions. Next question I'm looking at is petrol and diesel are used as fuels for cars. They've investigated the emissions, and you've got a car with no catalytic converter. You've got a car with catalytic converter, and you've got a car using diesel. Discuss and compare the impact of the environment. Discuss and compare on the emissions using information in figure 9. What I would tackle here, or what I would do here as a comparing and contrasting, is this. First of all, you could look at simple comparisons. For example, diesel produces less carbon monoxide. Car with catalytic converter using petrol produces the least nitrogen monoxide, or releases. Diesel releases least carbon dioxide. Petrol cars release no carbon particulates. So we're not really giving which is the best one. We're actually just analyzing and comparing and contrasting. So that for me simply would get you at least level 1, 2 marks. Okay. So now let's look at what are the, what's the problem with carbon monoxide? What's the problem with nitrogen monoxide, carbon dioxide, and carbon? So carbon monoxide is a toxic gas that combines with hemoglobin in the bloodstream. It replaces oxygen, and it could lead to brain hemorrhages. Nitrogen monoxide causes acid rain and also photochemical smog. They can prevent sunlight hitting the surface of the earth and making everything looking dark and dreary. Acid rain also. Carbon dioxide is a greenhouse gas, and you can talk about greenhouse. And carbon particulates basically can settle on lungs. They can cause breathing problems, can make asthma worse, and they can make the buildings look very dirty with settling on those buildings. Okay, so pretty much I think if you do all of that, that gets you level 4 at least, level 2 at least. What about catalytic converters? Catalytic converters, if you compare the car with and without catalytic converters, you will notice that catalytic converters convert carbon monoxide and nitrogen monoxide into less harmful gases, like nitrogen monoxide into nitrogen and carbon monoxide into carbon dioxide. So a catalytic converter reduces the amount of carbon monoxide and nitrogen monoxide released into the atmosphere. So overall, diesel is better than petrol for carbon oxides, and diesel is worse for particulates and for nitrogen oxides, and petrol car with catalytic converter is better than petrol car without catalytic converter. Again, will this question come up? Possibly, but not maybe not as 6 mark. Another rate question. Now notice now they've given you the equation. They've asked you that investigation is carried out into rate of reaction between calcium carbonate and hydrochloric acid. In the first instant, you've got concentration of hydrochloric acid is 0.5. In the next experiment, the concentration is 0.1, so it's doubled. 5 gram of small lumps of calcium carbonate were reacted. Another 5 gram of same, so they've kept the surface area. They are changing the surface area, look, small lumps and large lumps, and the two experiments were then repeated with small lumps and with large lumps. So they've done two things again. They've changed concentration and they've changed surface area, but they've kept the temperature the same. Okay? And the question then says, explain in terms of collisions of particles how these results show the effect of size of the lumps and effect of concentration. Now I've already talked about concentration for you. So we've already mentioned concentration. So doubling concentration means there are 2 times as many particles colliding in the same volume of solution. Number of collisions doubles. Therefore, frequency of collisions doubles. More successful collisions per minute per second, and more collisions collide with energy greater than activation energy. And that's A-level terminology here. Okay, that's A-level terminology. What about surface area? So small lumps have greater SA for surface area. So now look here, volume of gas collected, more volume collected compared to small lumps. And again, you can see here, okay, so small lumps, greater surface area. Greater surface area means more room or more space for particles to react. And then the rest, frequency of collisions goes up, more gas is produced because frequency of collisions goes up, more successful collisions and more frequent collisions, and more particles have energy above activation energy. So now you can see that's rates 1. Okay, next one again is a ion identification question where we've got to identify ions. So the question is, the student tests solutions of 3 ionic substances, KLNM. They add dilute nitric acid and silver nitrate. That to me will tell me halide test. They add few drops of sodium hydroxide. That is precipitation test. That is also, that could be testing for metal ions or for ammonium. or metal ions. Okay, so I'm just going to look here, explain which part of each conclusion is justified and what further work can be carried out to justify the conclusion. Look, explain each part. So I would say this: if test 1, okay, so if test 1 gives you white precipitate, that means K and L must contain chloride ions, because chloride ions, when they react with silver nitrate, they produce, look, this is the ionic equation, a white precipitate of silver chloride. M does not contain any halides, so no halides here. Forms a green precipitate with sodium hydroxide, so it must be iron sulfate. Well, it is iron, so it does contain iron too, so I agree with that. However, sulfate needs a further test with a solution of barium chloride. So I would get that mark. Now let's look at K and L further. So definitely the chloride has been justified. I would say aluminium, yes. Aluminium, yes. Not definitely yes, because when aluminium ions react with hydroxide ions, they form a white precipitate of aluminium hydroxide. However, to confirm this further, I would add excess sodium hydroxide, and this precipitate dissolves in excess. So that would confirm that. What about ammonium? You would warm the mixture for ammonium ions. However, you need to test with damp red litmus paper. So we've already looked at this, and that should give you a blue precipitate. The litmus paper should turn blue. That proves it's ammonia. Okay. Now, what else? Describe how sodium hydroxide solution can be used to do ammonium ions. We've done this now. You see how many times these questions are repeating. These are all past questions over the last 5-6 years I'm looking at. Now, look, aluminium reacts to form a white precipitate. I've already done this for you. Let's do this again. Okay, there's no harm in repeating things, because the more repetition, the better at learning. Okay, so now let's go into this question, and you will see some repetition here now. Okay, one more thing here. Let me look here. It says complete the sentence by putting a cross in the box. A test was carried out to find out which anion, negative ion, is present. Dilute hydrochloric acid is added to substance X. Effervescence, so it must be carbonate, because when carbonates react with acids, you get carbon dioxide and water given off. Okay, let's look at this question. A technician found some colorless crystals of substance left unlabeled. Right? Classic context in this question. Okay, now she knew the substances are potassium sulfate, potassium iodide, and sodium sulfate and sodium iodide. Explain how, using chemical tests, the technician could find out the substances left in the beaker were those. Include any equations. Right, lovely question. I would say, it's a question of just learning these tests. We have already looked at some of these as we've looked at the previous questions, but let's go through these and see how we do the test. Number 1, to test for metals, then we do a flame test. They're not asking you how to prepare it. So flame test means you take a nichrome wire, dip it in the solutions of each one, and then blue flame, potassium ion gives you lilac color, and sodium ion gives you orange color. Actually, if these are solids, make them into solutions first for the next test. So dissolve these ions in water now. Okay. The way we test for iodide, we will use silver nitrate acidified. So I'm doing the ionic equation here. So you add acidified silver nitrate to Ki to the 4. The ones that give you a yellow precipitate, they contain iodide. So we eliminate iodide. And we've also eliminated potassium and sodium. And to test for sulfate, we add a solution of barium ions like barium chloride, and you will get a white precipitate of barium sulfate. You give your equations, you give your observations, nice, easy, 6 marks. Okay, right, moving on then. When you have a graph like this, and if the question says, work at the rate at 20 seconds, and we need to take a tangent here. So tangent is basically, I'm gonna do this freehand, but you need a ruler, and basically the gap here and the gap here needs to be similar in terms of area, and you just take the gradient of that line. Okay, right, moving along. I'm just going to look at, okay, this question again is repeated as one we've done up there. Those of you who are my students, I've already emailed this to you, so you can have a look at this. Explain how the results show a reactions exothermic. So heat changes is mentioned. Well, the temperature has gone up. So if in a reaction the temperature goes up, okay, so if the temperature increases, then that reaction is exothermic because heat is released. 1 mark, temperature's gone up, heat is released. Now, as a reaction progresses, reactants become products. On the axis below, draw labeled lines to show the relative heat energies of reactants and products in an exothermic reaction. In an exothermic reaction, reactants have more energy than products. This arrow that goes down is energy or heat released. So heat released. It's exothermic. So the arrow goes down. All the arrows that go down in this graph is exothermic. And if you were asked to show activation energy, then there's your activation energy. Arrow must go up because activation energy is always endothermic. Now, how do you improve an experiment here? You use a polystyrene cup, because polystyrene cup is an insulator. It insulates it, reduces heat loss. I'm looking at a practical here really on this. Oh yes, so I've got some AQA question. I just picked a couple of AQA questions here. The reason is because there is a bit of a challenge in some of these questions. And if you were to get a practical on heat, how do you measure whether the reaction is exothermic? What's the investigation you can do? So let me explain that here because that could come up. Polystyrene cup. Place a solution A. Put a thermometer in there. Put a lid. Measure your initial temperature. Add the second solution or solid and measure the maximum temperature either goes up or goes down. If it's exothermic, the temperature will go up, heat is released. If it's endothermic, temperature will go down. So an acid-base reaction between hydrochloric acid and sodium hydroxide, exothermic. Copper sulfate and zinc, a metal displacement reaction, it's again exothermic. Two very common reactions that they do ask about. So now let's look at this. Now what do you notice here? This is a reaction between sodium hydrogen carbonate and hydrochloric acid. So this reaction is basically an acid-base reaction. So what do we notice? The temperature goes down in this reaction, isn't it? It's gone down by 4, 6, 8, 10, 10, 10. So it's endothermic. Describe as the trends shown in the student's results for 3 marks. So for the simplest trend is that the reaction between, it's endothermic because as you add sodium hydrogen carbonate, the final temperature drops. The greater the amount added, the bigger the drop, up until 8 spatulas. Spatula 10 and 12 is no change in temperature. The change in temperature is the same. So what does that mean? The temperature becomes constant after 8 spatulas. Reaction's gone to completion. Okay? State the type. We've already mentioned that it's endothermic. Another type of a question, sodium hydrogen carbonate decomposes. Okay, use the equation to suggest why the cake mixture rises, because carbon dioxide is produced, it's a gas. Okay, the same reaction can be reversed. Do the reactions need to be heated? Not now, because the reaction is exothermic, so it doesn't need much energy. Okay, I'm just going to look at this question for you. So this is a student did an experiment to find the energy released when propane is burnt. Put 750 grams of water into the beaker. Measured the temperature of the beaker at the start, which is 17 degrees. Heated the water by burning propane. Measured the temperature, and the temperature has gone up. So it's an exothermic reaction. The student calculated energy released using the equation Q equals M times 4.2 times change in temperature. You've come across this equation in physics. It's not directly mentioned in Edexcel. The only reason I'm mentioning it here is just for you to understand the heat changes that happen in reactions, and on the additional information there is a mention of heat release experiment. So we'll basically use the student's results to calculate the energy released in joules. So the change in temperature, so the mass is 750 times 4.2 times the change in temperature, and that's all they would be doing here. But I just gave you that just to understand what's going on. To find out how much propane has been used in before the mass of the decrease using the, okay, this part you're not expected to know, they're not going to ask you this thing. And the last thing I just want to go over is a question of this nature where you have bonds broken and bonds formed. So using the experiment, bonds broken and bonds formed to work out enthalpy change. Yeah. So you would have to draw out the bonds broken and what's formed, and use the values for each bond value, work out bonds broken, value for bonds formed, and then take the two away from each other. Okay, so those are the other types of questions we would work. It says calculate the energy released by bond making when products are formed. So you've got 2 CO bonds there, two OH bonds there. In total, you formed 3 carbon dioxides, so that's going to be in total 6 CO bonds. You formed 4 waters, so that will be 8 OH bonds. So 6 times 830, add 8 times 464, and you can do your calculation yourself. Then it's saying the energy used for bond breaking was that, so the overall energy change will be 6481. The value you should get for the top part was 8530, and then you work out the overall energy change. Again, another type of an experiment there, where you're using alcohol to heat 50 grams of water. Okay, so you're measuring the initial temperature, then you're measuring the final temperature, and you're substituting that value in there. The mass is the amount of water that you're heating, so it's 50 times 4.2 times the change in temperature, which is 38.4 times 22.8. You do need to have a go at how you would do this experiment. So I hope some of those questions I have been through will help you in preparation for the exam on Monday. Thank you very